Hi everyone and welcome. In this lesson, we'll explore simplifying rational expressions. Remember that a rational expression is simply a fraction that contains algebraic expressions. Now, the denominator in a rational expression contains a variable, and this is very important. So the denominator must have a variable, and not just one variable. Sometimes it can be a combination of multiple variables. So the numerator, on the other hand, can be either a polynomial or an algebraic expression, or a constant term. Now, I wanted to think what happens if a rational expression has a constant denominator. So, see how we emphasize here that the denominator has to have a variable, right? But the numerator can have a constant. Now, what would happen if the denominator has a constant? And for this, I'm bringing an example, a very simple example, 10x plus 15 divided by 5. So, as you can see here, the numerator is an algebraic expression, denominator is a constant number. And if you remember how we added fractions, we made sure that the fractions had common denominators before adding them, which means that we can also split this. So we can split this into 10x divided by 5, and then plus 15 divided by 5. And if you go backwards in here, and we've done plenty of these type of exercises, so 10x plus 15 divided by 5, that's what we have. Now, if you simplify this, 10x divided by 5, we get simply 2x, and 15 divided by 5, we get 3. So as you can see in here, this is simply a polynomial expression, so it doesn't qualify to be a rational expression. So just be mindful of that. So the numerator can be a constant number, but the denominator cannot. So a numerator can be, let's say, for example, 2 over x. That's a rational expression. But if you write x over 2, that's not a rational expression. So it's simply a monomial term. Now, whenever we simplify rational expressions, first of all, that's what we're going to do mostly in the first lesson. We talk about something we call restriction. So we're going to mention this term very, very often. So I'm going to start off with some very basic knowledge and some very basic examples so that we can understand where the restrictions come from. Because I notice that very often when we learn algebraic rational expressions and we say restrictions, and everybody say restrictions, but they don't exactly know what they're for. So it's important to understand why do we have them in the first place. So here is the restriction story. So when we divide two numbers, it's easy to evaluate the answer because we can use a calculator to divide it, or we can just do it mentally. So if it is something simple, why not? And we simply divide to get the value of it. So 20 divided by 5, and I know you're thinking that's a 4. 1 divided by 2, that's a 0.5. 6 divided by 0.01, that would be 600. 135 divided by 3, I have to think a little bit about this. So it seems that it's going to be a 45. And 9 divided by 7, it's going to be 1 and 2/7. So that would be the mixed number. And there you go, we performed the division. Now, when we divide rational expressions, we said that the denominator will contain a variable. So I brought some examples, different examples, where the denominator contains a variable. So we're going to start with the first one. So 3 divided by x, by the way, is the most simplified form it can be. And now we're thinking, what if, x, first of all, is a variable, and the term variable means that it can vary in value, right? So we don't know the exact value. But if we give specific values to x, then we'd be able to evaluate what 3 over x would be. So if I ask you to substitute x by 1, or find the value of the expression when x equals 1, then you would say, well, that's easy. 3 over x will be equal to 3 over 1, and the value of the expression would be 3. So if I ask you to evaluate this expression for x equal to 0.01, then you would say that 3 over x will be equal to 3 divided by 0.01, or 300. So I'm going to take another example. So let's say x is equal to -2. And then you're going to say that 3 over x is going to be 3 over -2, or -1.5. Now, if you were asked to evaluate the expression for x equals 0, then you're going to say, okay, so I can do this. I know how this works. You just substitute x with whatever value it equals. And in this case, you see that we get 3 over 0. And if you try to do this mentally, you probably can easily see that this is an undefined expression and the calculator will give you an error. And that is because the division by 0 is undefined. So we are going to say in this case that for this particular expression, 3 over x, right? X can be any real number, but has to be different than 0. So it cannot be 0. And this is exactly what restriction is for this particular expression. So the restriction will be x different than 0. And I'm going to try to make this look a little bit more organized. So let me just make it smaller. And we're going to look at these other examples together. Okay. And this one should be okay here. And we're going to move on to x plus 1 divided by 5x. So from what we see here in the previous example is that x equals 0 made the denominator 0. And that's the reason why this expression became undefined at x equals 0. And that's why we say that the restriction is x different than 0. Now we're going to take a look at the next example. So we have x plus 1 divided by 5x. So again, I'm going to go over the routine process. If x equals 1, let's say, then we're going to have x plus 1, 1 plus 1 over 5 times x, so 5 times 1. So we are replacing x by 1. Wherever we see x, we replace it by 1. And we'll see that the value of the expression will be 2 over 5. So we're going to say, in other words, so the value of the expression at x equals 1 is going to be 2 over 5. Now, let's say that we want to give the x, variable x, a value of negative 1. So if x equals negative 1, then we'll have negative 1 plus 1 divided by 5 times negative 1. So in this case, the numerator will turn into 0. Negative 1 plus 1 is 0. And denominator is negative 5. And 0 divided by negative 5 is equal to 0. And you see that x equals negative 1 makes the numerator 0. But still, the expression is defined. It has a value of 0. So you probably have guessed what value of x we're going to try this time. So we're going to get x to be 0. So that means 0 plus 1 divided by 5 times 0 would be equal to 0 plus 1 is 1. And 5 times 0 is 0. As you can see, this will be undefined. So guess what? We're going to say that x equals 0 is a restriction for this expression. So therefore, we're going to say that x has to be different than 0. And that would be the restriction for this particular rational expression. Now, we've seen that in both first examples, x had to be different than 0. One of the common mistakes people make is that, oh, so in every rational expression, x shouldn't be 0. Well, that's not really true. So, and that's what we want to actually analyze in the next example. So what you see in the numerator here, we have a constant, still a rational expression. Numerator can be a constant number. Denominator is an algebraic expression that contains a variable. So we're going to say that this is a rational expression. It's a legit rational expression. So we're going to say that if x equals, so we're going to try a couple of values in here. Let's make them colorful. So if x equals 1, then we're going to have 2 divided by 1 minus 4 equals 2 over negative 3. And that would be the value of this expression. So if x is equal to 0, let's try 0. That would be an interesting number to try. So 2 over 0 minus 4 would be equal to 2 divided by negative 4, or negative 1 over 2, or you can write negative 0.5. So as you can see in here, x equals 0 is not a restriction. And I want you to think about it. Why is that? What is the restriction really, right? So the restriction is the value of x that makes the denominator 0. So it's time for us to define this. So restriction, or should we say restrictions, because sometimes there may be more than one restriction in a rational expression depending on the size of it, are the values of x that make the denominator 0. So from now on, we are going to define the restrictions faster and simpler. Just focus on the denominator. And as you can see here, we have a denominator of x minus 4. So we're going to say x minus 4 is not allowed to be 0. And this works just like equations, okay? And when you solve this, you simply isolate the x, and you take negative 4 to the other side, and you're going to say x has to be different than 4. And that's the restriction for this particular expression. And if you're not convinced that, yeah, that's the one that we need to, get for restriction, so just substitute x by negative 4 in here, and you see that 2 divided by 0. Positive 4 in here, and you will see that 2 divided by 4 minus 4, that would give us 2 over 0, so that makes it undefined. So again, one of the things that I wanted to learn, from the very start of studying the rational expressions is that the restrictions are the values of x that make the denominator 0, and the restriction is not necessarily x equal to 0, because I've seen that very often in every year in many occasions, when people state the restrictions, they start with 0 because 0 is the dangerous number. Well, 0 is not the dangerous number. It's the whatever values of x that can make denominator 0. Now, the next example is a little bit different. So in this case, we have not just one, but 2 variables. Now, you know that in multiplication, if one of the factors is equal to 0, remember that when you have the product, it means that these are factors in the denominator. So if either one becomes 0, then the entire product will be 0. So we're going to say that xy has to be different than 0. And what that means is that x has to be different than 0 because 0 times y will make denominator 0. And also y has to be different than 0 because, again, x times 0 would be equal to 0. So therefore, we're going to say x different than 0 and y different than 0 are restrictions for this particular example. Now, moving on to the next one, and you will see how quickly and how fast you're going to be at defining the restrictions. Here is another example. So we have x divided by x minus 2. Now, I want you to think, do you have to worry about the value restrictions of the numerator? Do you have to worry about whatever values of x are allowed to the numerator? And the answer to this is no. It's only the denominator that we don't want to be 0. So x minus 2 different than 0, so x is different than 2. Okay? Now, and usually we're just going to mark in here, so these are the restrictions in this case, okay? And there is only one. And now let's take a look at another example, slightly different. So as you can see in here, the numerator has just a constant number and denominator has 2 factors, each of them in binomial form. And if either factor has a value of 0, 0 times anything will give 0, right? And anything times 0, so if this becomes 0, anything times 0 will be 0. So therefore, we're going to say that if you want to state the restrictions, then you have to make sure that The first factor is different than 0, and the second one is different than 0. So x minus 4 different than 0, and x plus 1 different than 0, which means that x is different than 4 and different than negative 1. And these two conditions must be satisfied simultaneously. So it's not that it's one or the other, but it's one and the other. So x different than 4 and x different than negative 1. Now, restrictions, remember, are the values of the variables that give the denominator a value of 0, and this is the most important thing that we need to take from this small little exercise here. In the next example, we're going to take a look at how we simplify rational expressions, because that's going to be our focus for now. So remember that the difference between the simplifying factors and simplifying terms, right, is the following. Now, factors are separated from each other by a multiplication sign. Well, sometimes division, we're not going to get that far. We're just looking at the normal, algebraic factors, okay? Now, terms, on the other hand, are separated from each other by the plus or minus sign. So it's either addition or subtraction. So what does that mean? So if you have 2 times 3, so therefore, we're going to say that 2 and 3 are factors. Let's say if you had 1 divided by 2 times 3, 2 and 3 are factors. But if we have, for example, 1 over 2, let's say plus 3 here, then we're going to say that numbers 2 and 3 are terms, so they're not factors. Now, the reason why we want to mention this is because it's important to be able to identify the factors correctly in an expression, because factors can divide into each other and simplify the expression, but terms can never divide each other. Okay, or cannot divide each other or simplify. So let's take a look at some examples, okay? Now, if we have, for example, 7 times 4 over 2 times 35. So 7 and 4 are factors in the numerator, 2 and 35 are factors in the denominator. So as you can see in here, 7 and 35 have a common factor of 7. So you can rewrite this as 7 over 35, right? And 4 and 2. So I just rearranged in multiplication. The order doesn't really matter. And 7 will simplify 35, and it will give 1 over 5. And 4 can simplify 2. And that will give 2. And the simplified expression here would be 2 over 5. Now, in the next example, I'm using the exact same numbers, but instead of multiplication, I've put the addition symbol in between, because that's what we have, 7 plus 4 over 2 plus 35. So in these cases, 4 and 2 cannot combine together to make, to simplify, all right? So we can only simplify 7 and 35 or 4 and 2 when they're factors of both numerator or denominator. But when they are terms, right, because they're separated by a plus in this case, right, so they cannot simplify. And the correct way of doing this would be 7 plus 4 is 11, 2 plus 35 is 37, and this would be the exact value of the expression, so the exact answer. And I see very often people mix this up with simplification, the way that it works with factors, and they would take 7 plus 4, 2 plus 35, and then simplify the 7 and the 35, and simplify the 4 and the 2. So we can't do this. So that would be wrong. So it cannot be equal to, say, for example, 1 plus 2 divided by the 2 simplifies to 1 plus 35, which is 7. So that would be incorrect, okay? So again, always remember, terms are separated by either a plus or a minus. They don't simplify, so they don't divide into each other. Only factors do, right? Now, in the next example, we have something similar. So this is for you to practice on your own. So if you have 5 times 33 over 15 times 3, so these are factors. So that means they can simplify. So which means that we can get 5 over 15. So that would be equal to 1 over 3. And then 33 over 3 would be 11 over 1. So that would be equal to 1 times 11, 11. 3 times 1 is 3. 11 over 3 is the answer. However, when you have 5 plus 33 over 15 plus 3, that would be simply 38 over 18. You can reduce this to lowest terms possible. So that would be 19 divided by 9. That would be it. But you cannot simplify the terms. Now, next, we're going to look at some expressions that have variables. So again, these are factors. That's a factor. So let's highlight them. So x7, x3 are factors, and y squared and y, these are factors. Now, you also have a coefficient here, numerical coefficient, and that's totally fine. You count this as a factor as well. So x to the 7 over x to the 3, so you can also split them, right? So if you wish, if it makes it easier for you. And that's because in multiplication, we just multiply numerators together, denominators together. So x7 over x3, that's x to the power 4. And then y4 over 5y is y over 5. So this is simply x4y divided by 5. And obviously, you can do this the shorter way, okay? Now, on the other hand, if you have x7 plus y2 over x3 minus 5y, you can't simplify this. So there are no like terms in here, right? In the numerator, no like terms in the denominator. That's all you can do. And there is nothing that you can factor out and simplify. So this is the simplest it can be. Now, next we're looking at something similar. So similar idea, but we're moving to binomial factors. The idea is the same. As you can see here, we have x minus 4 to the power of 3 and x minus 4 to the power of 2. So you're going to work out just the exponents. So that would be x minus 4 to the power of 3 minus 2. So you don't have to show this step. I'm just explaining it for now. And also we have 2x plus 9 to the power 6, 2x plus 9. When you see no power, it means that the power must have been 1. And that will give 2x plus 9 to the power of 6 minus 1. So this will turn into x minus 4, and then 2x plus 9 to the power of 5. That's the most simplified form. On the other hand, if you have a plus or even a minus sign between the binomials, to the power 3, power 6, can do anything, okay? So this is already simplified. All right. So we haven't started working with rational expressions yet, but I think that it was very important that we went over some of the very, very important details about our practices that we need to follow when we simplify rational expressions so that we can do them faster. So follow in the next video for the rest of the lesson. Bye for now.